So imagine that we have 50 people living in an area. We know the ages of those people, and we know that the average for all of those people together is 25. Great. But what if, instead of looking at the average for all of them, we divided them into two different groups, two different zones, and took the average of those? Now it turns out that the one group on the left has an average age of 20, the one on the right has an average of 30. Those are both quite different than 25. Same people, same ages, same data, but just by dividing them up differently, we've come up with a different answer, a different solution, different data points, which is something that you need to be aware of. When this is aggregated, by the way, just remember that what you have to work with is these two areas with two numbers. So all we have is a 20 and a 30. We don't get to see any of the original data if it's, say, census data or if we've generalized it ourselves. All we have to work with is this 20 and a 30. Now, what if instead of dividing it into two zones, we divided it into 5 zones and took the averages of those? This is what we get now. So 2 of them actually have averages of 20, one has a 22, one's a 25, and one's a 38. So again, very different results. Same starting point, same data, but just based on the fact that we've divided it up differently has given us different results. And this would be interpreted differently by someone who was looking at it. This is referred to as the Modifiable Areal Unit Problem, or MAUP. And what this is essentially is a way of recognizing that there are limitations whenever you generalize or aggregate data in some way. So there's good reasons to do that. You may want to simplify data so it's easier to interpret. You may be trying to protect somebody's privacy, but there's always a bit of a trade-off when that happens. And you may have control over the boundaries that are used to do this, or you may not. If you're downloading data from a census website or something like that, someone else has made those decisions for you. But even if you're collecting the data yourself and generalizing it, you should be aware of the fact that there could be errors being introduced based on the boundaries that have been drawn. There's 2 different effects that are often referred to as being part of the MAUP. This one is referred to as the zone effect. So in other words, we have one size area with one set of data, and just by dividing it up into different units based on moving the boundaries around, we've created different zones that are giving us different answers. So that's referred to as the zone effect of the modifiable areal unit problem. A different effect that can come up with the MAUP is the scale effect. And what that is imagine if you have data at one scale such as this. So this is for the city of Toronto, and these are data points at the census tract level. If I take that same data but aggregate it according to the neighborhood level, so those are larger areas than census tracts, we get a different pattern. We have a different type of aggregation that's been done, and we'll see different things based on these different sized units. What if we went a step further and aggregated based on the entire city itself? Well, you may think that's a little bit ridiculous, but if you're comparing one city to another, it's quite possible that that's what you would end up doing. So this is referred to as the scale effect. So it's still a modifiable areal unit problem in that you're looking at different ways of aggregating the data based on the geography of it. But in this case, instead of it being that it's the same size area and you're just changing the boundaries that you're using to divide it up, here you're using different scales. So you're looking at small units versus larger units versus larger units. Think of it maybe this way: is, you could have one average for an entire country, you could have an average for each province or state, you could have an average for each city, you could have an average for each neighborhood. That's the scale effect that can happen with the MAUP. So here's the side-by-side comparison just to make sure it's clear. We have the zone effect and the scale effect. They're just 2 different parts of the MAUP. One thing to keep in mind is that you may actually have both of these things happening at the same time depending on what data it is and how it was aggregated. And maybe you're asking yourself, okay, so what do I do about this? Often, there's not a lot that can be done. Sometimes you're using data where you don't really have a choice. It just exists as it is. Sometimes you do have a choice. And if you do, one way to look at this or approach it is to say, well, what are the smallest units that I can use that are not too small in that we're going to have too much data or it's going to become too difficult to interpret, but that I can still get a useful amount of variation, be able to see patterns, be able to see what's going on. In other words, it's easier to start with small units and then aggregate up from there if you need to. But if you start with big units, you can't see the data inside those units. You can't associate that with anything else because of the ecological fallacy. So always start with the smallest units you can, look at what's happening there, and then you can work your way up from there and generalize more broadly if you need to, if that makes sense.